Welcome to lesson 4 of our BI course. Today we are going to learn more about data warehousing. We are going to build directly upon the foundations that we established in lesson 3 and we are going to proceed from there. The data that is lying inside a data warehouse can be categorized as three main types. They are metadata, detailed data, and lightly and highly summarized data. Let's see what these are. Metadata is data about data. These data provide information about the structure of the data warehouse, about the characteristics, attributes, and the context of the data that is stored inside the data warehouse. So it basically gives some additional information about the data, right? So that can be operational metadata that have details about all the operations, and then there is extraction and transformation metadata. These will tell us how the data is extracted, the transformations that are used on the data before they are stored, the business rules that are applied, and then it can also contain data about the end users. And then we can have detailed data. This is also known as transaction level data. If you remember last lesson, we discussed about transaction fact tables. So that is that type of data we are talking about here. This contains granular information that is captured at the lowest level, and it represents individual events or transactions that contains all the available attributes and the information associated with each event. So this is highly detailed data about every transaction. So this type of data is essential to conduct in-depth analysis. We sometimes need all the details. We can't always summarize the data and store it, right? So detailed data is necessary. So we can conduct in-depth analysis, we can understand specific patterns, and we can also perform more accurate calculations because we have more details about each transaction. And this detailed data is stored in the database schema, and in most cases the detailed data is not stored online, but it is aggregated to the next level of detail. Based on the purpose the data warehouse is used, based on the types of analysis that is required using the data warehouse, it might be aggregated to the next level. So on a regular basis, detailed data is added to the data warehouse to supplement this aggregated data. That can also happen. Then we have summarized data. So summarized data can be further divided as lightly summarized data and highly summarized data. Another name for lightly summarized data is moderately aggregated data. So this data has undergone some level of aggregation or summarization, but a moderate level of detail is still there, right? We have not completely aggregated or summarized. What do you mean aggregated or summarized? What are the operations that we can perform, right? So we can take the summation over a certain attribute, right? We can take the count, we can take the average. So these type of operations are what you call aggregations or summarizations. So these are the examples. Aggregating customer data by demographics or behavior. So this can allow to create meaningful customer segments. Then aggregating website traffic data by time periods and user attributes, right? So website traffic data can be the summation can be taken for a particular time period for a particular user, right? So this will help in understanding peak usage times and usage behaviors. Then we have highly summarized data. This is known as aggregated data. So if you hear the word aggregated data, we are talking about highly summarized data. So this data is significantly condensed and simplified. So who needs these type of data? So this senior management who are very busy people, they only want to look for a particular information. So when we create dashboards for these people, to present for these people, we create high level KPIs and metrics. So these are highly summarized data, right? So they are very easy to understand. Straight away you look at the dashboard and you can get the information you need. And also regular performance reports, right? They summarize organizational performance over specific periods, and they highlight the trends and key achievements. So not much detail is there. The purpose of summary information is basically to speed up the performance of queries, right? So you don't need to do all the calculations using detailed data when you already have the summarized data. So it's going to speed up the performance of the queries. And you don't need to do it over and over again, right? If you have a certain business process and you know what the information you need, right? You don't need to continually perform summary of operations to answer the queries when you have the setup with the highly summarized data. And the summary data is updated continuously as new data is loaded into the data warehouse. We will further understand about dimensional modeling. Last lesson also we covered some few concepts, but here we are going to learn a little bit more detailed things about dimensional modeling. Basically, dimensional modeling, we have facts and dimensions. Facts are the numeric values like sales amount, tax paid, and then dimensions are the descriptive attributes, right? They describe these facts. It can be date, product, geography, customer, things like that. So facts are the ones that we actually use for aggregation. We can take the sum because they are numeric values. We can count, we can take the average. And to do those aggregations, we can use dimensions for grouping and summarizing. Let's see how this is done using an example. So this is a bookshop OLAP system, right? And the bookshop needs to analyze its sales by product, geography, and time. So whenever a transaction happens, all the details you can see are in the fact table, right? You can have the amount, right? The selling amount, the ticket number, the ISBN number of the book, the warehouse code, and the date. Those are there in the fact table. So the fact is the selling amount, right? And then this fact table is connected to day, books, and warehouse. So these have the details about the warehouse, right? These have details about the day, and then these have details about the book. So you can see that the warehouse is further connected to sub-region and region. So the dimension tables are normalized. The day is also normalized. So this is a snowflake schema, right? So this is the OLAP system of the bookshop. And now what is the question? Obtain the total daily sales by book and sub-region, right? So let's look at the query, SQL query written to get this information. To get the total daily sales by book and sub-region, you have to select the dimensions, right? So these dimensions help us to summarize. And then we have the facts. We are interested in total sales, right? So you take the summation of the sales for that sub-region, day, and the book, right? And then you can see you use the dimensions to group by, right? So the dimensions help us to group by, and the facts help us to do the aggregations. So finally, when you write the SQL query like this, you can get this table. There's a subregion, the day, the number of the day, the ISBN, the title of the book, and total sales, right? So this basically answered our question. Let's learn about data marts. So data marts can be considered as a specialized type of a data warehouse that contains data that is specific to a particular group. So this can be a department in the company. The marketing department can have a separate data mart. We don't call it a data warehouse, we call it a data mart. It will only contain marketing data, right? Data related to the items, customers, and sales, right? So data marts are smaller in size than the data warehouse. So it's easy to handle data marts rather than considering the whole data warehouse. So each department can have a data mart that contain the data specific to that department. Even in the architecture of a data warehouse, you remember the storage, the database management system of the data warehouse can be there, but it can be made of different types of data marts. Then another important concept when we think about data warehousing is data lakes. This this concept came with the big data storage and processing challenges. So you can understand that when big data is streaming from different sources in varying formats, right, in different structures, right, and in different speeds, so it's a huge challenge to ingest this data into the data warehouse. So you need fast and scalable storage systems, right? And they have to be flexible enough to serve many different analytical processes. So it was a huge challenge. So because of this, the traditional data warehouse with the strict data models and data formats, it did not fit in to this concept. So to answer this big data challenge, this data lake concept was introduced. Let's try to understand how a data lake works. First of all, the data gets loaded from its source, and then it is stored in the raw native format. Until it is needed, it is stored in the raw format. Then at the time of application, it can freely read the data and add the necessary structure or data model to the data. So this is called schema on read. This is different from the traditional data warehouse, where the data is loaded into the data warehouse after transform it, right? We apply ETL and transform it into a well-defined and structured format. This is what we call schema on write. So any application using the data will need to know about this format in order to retrieve and use the data. And in this approach, data we don't load into the data warehouse unless there is a need for the data. However, in the data lake, which applies this schema on read, it ensures that all the data is stored for use at a later time, right? So there is no filtering of the data in the data lake. When we consider about data storage methods, in the traditional data warehouse, the data is stored in a hierarchical file system, and it has a well-defined structure. But in the data lake, the data is stored as flat files and each file will have a unique identifier. This is also called object storage in big data systems. And you can further compare along other characteristics the data lake and the data warehouse. The data lake store vast amounts of raw and unstructured data in its original form, and until they are needed, they are stored in a single repository that will serve multiple analytic use cases or services. So because we store the raw data, we haven't still decided for what we are going to use it, but anyway we are going to store the data. So once we have some use case, the data is pulled and organized. So, but in the data warehouse, the structure and format of the data is decided when the data is loaded into the data warehouse. Because if we don't need the data, we know the purpose of storing the data, we have a particular structure, right? So that is the difference between the data lake and the data warehouse. Then, as we said, the data lakes use a flat architecture for storage, unlike the data warehouse. The data warehouse use a hierarchical file system. Then data lakes are typically used to store data that is generated from high velocity, high volume sources, right? Big data sources like IoT, product logs or web interactions. And when the organization needs a high level of flexibility in terms of how the data will be used. Then data lakes can offer great value and high scalable flexibility. So all these characteristics are in the data lake. The slowly changing dimensions problem is a common issue that arises in data warehousing. This basically happens when the dimensions for a particular record, right? The value of the dimension for a particular record changes over time. So let's look at ways that we use to tackle this issue. Now let's say we have a particular customer, right, in our data warehouse. So we have the address of the customer. She lived in Chicago first, right? So this is how the original entry will look like. But at a later date, the customer changed the location, right? The person's living location is changed. In 2003, she moved to Los Angeles, California. Now how should the company incorporate this change? This is what you call the slowly changing dimension problem. There are three main ways we can identify to solve this problem. Type 1 is basically we replace the original record and there will be no trace of the original old record. That's type 1. And then type 2, we can add a new record about the customer. So now the customer is treated as a new customer. So two people. We have two records for the same person. Then type 3, the original record can be modified to reflect the change. So this is how the type 1 solution is applied. You can see the first table and then that first state, previous state is deleted and this new state is added, right? So the new information simply overwrites the original information. No history is kept. Advantages is this is very easy. There is no need to keep track of the old information, right? And the disadvantage is all the history is lost. So you don't know when this customer changed the location. That might come useful for different types of analysis. So there is no way to go back and trace the history, right? So that is the disadvantage of this method, and this method is not much used. And this is actually used and should only be used when it is not necessary for the data warehouse to keep track of the historical changes that happens to the customers. So if that is the case, one can use this technique for the slowly changing dimension problem. Then the next type 2 solution is a new record can be added to the table to represent the new information. So you can have a new primary key for the new record, right? So both records are going to be present in the table, and basically we will have to consider the two records as two customers. The advantage of this method is it allows us to accurately keep all the historical information, but the disadvantage is, so the more records are added, it will cause the size of the table to grow fast, right? And the storage performance is going to become a concern. Then the ETL process is going to be complicated. You will have to apply more data cleaning to get information from this type of data. So this method is used about 50% of the time. If you have only a little bit of data and the storage is not a huge problem, you can apply this method. And then type 3 is there will be two columns to indicate the particular attribute of interest. One will indicate the original value, and then another column will indicate the current value, right? And there should also be a column to indicate when the current value became active. So you can see effective date is also there, right? Current state was changed on this date. That information is there. So the advantage of this method is it does not increase the size of the table, and it allows us to keep the history. But the disadvantage is what happens if the attribute is changed more than once, right? So how are you going to incorporate that? You cannot incorporate that, right? So that's a disadvantage. Then this type 3 solution is rarely used in actual practice. You can to further understand about slowly changing dimension, you can click this link and watch the YouTube video to understand about slowly changing dimensions. Then we have confirmed dimensions. Confirmed dimensions are standardized dimensions that maintain their attributes consistently across different data marts within a data warehouse. That means now different fact tables are associated with dimensions. Here the same dimension tables are associated with two fact tables. So the same attributes and the domain contents of a particular dimension table is relevant to two fact tables. So here you can see the time, product and staff dimensions. The same attributes and the domain consents are shared with the sales and inventory fact tables. So the sales fact table, what is connected here, can be considered as the sales data mart, and what is connected to the inventory fact table can be considered as the inventory data mart. So two data marts are connected because of these confirmed dimensions. So when we have confirmed dimensions, data from different data marts can be integrated easily, and it will allow us to get accurate and meaningful cross-functional analysis. So in the same report, we can combine the information that we want from two different data marts. As we discussed in the last lesson, it's the business analyst who plays the critical role in understanding the business requirements, right? Through the conversation with the business user, the BA we'll try to define the KPIs and then translate them to build the dimensional model. So next we will see like a very simple example situation where a business analyst has a conversation between the business user and how he translates the details into the dimensions and facts to build the dimensional model. So you can see here the business analyst starts the conversation and asks about the details that the business user needs for the analysis, and then the business user will clearly mention what are the details. So here he says we are interested in understanding our sales performance, right? So that he wants to understand the sales performance across different product categories and regions. We want to know which products are selling well in each region, right? So that is one thing they want to know, and identify any trends over time, right? So then the business analyst further inquires, so you mentioned about product categories and regions, are there any other data points you like to include? So the business user says, along with the categories and regions, we also need to consider sales channels, right? Because they have online sales, in-store sales, and sales through distributors. So based on what they have discussed up to now, the BA now kind of summarizes what are the facts, right? So we are interested in sales revenue, quantity sold, and profit margins. So based on the conversation, he extracts these are the quantitative measures that we need in our dimensional model, right? Then again this is further clarified by the business user. We want total revenue, the number of units sold, and the profit margins. So there are other facts, right? And then further about dimensions of product category, region, and sales channel, right? So based on the conversation, now the business analyst can summarize this into facts and dimensions. So based on this business scenario, we are going to have a sales fact table, and what we have as numerical measures are total revenue, quantity sold, and profit margins. And this fact table will be connected to the product, region, and sales channel dimensions. So the foreign keys will also be included in the fact table: the product key, region key, and sales channel key. And the product dimension, the attributes for that will be, of course, the product key will be the primary key of that table, and then product category, what is the category, then region, the region name will be there, then sales channel dimension, the sales channel key will be there, and sales channel name, right? So based on the schema design, you can either further normalize these product dimensions to build a snowflake schema, or if you do not want to normalize the tables, you can keep it as a star schema. Then based on what we learned up to now we can understand how the data warehouse design process happens. First of all, based on the requirements of the business user, we have to decide the analytical and reporting requirements. What does the business user want to know? What information does he want to get? Then we have to identify what are the business processes that generate the required data. Then what are the source data for these business processes? After identifying the facts and dimensions, we have to identify whether there are any confirmed dimensions across business processes. So in the previous example, we only identified just one business process, but in a real world situation, there can be multiple business processes. So we have to identify those and then identify the confirmed dimensions. Then we have to prioritize processes and create a dimensional model for each process. We have to document and refine the models to decide the database logical schema. And then we have to design the physical data structures for the database. So in a practical situation, this might be an iterative process, but basically this is the data warehouse design process that is followed. When there are multiple business processes in a certain organizations, we use what we call a data warehouse bus matrix to identify the confirmed dimensions and their associated business processes. So this is a data warehouse bus matrix. So the rows of this matrix will have the business processes, right? And the columns will indicate the dimensions identified for each process. So when after we have the conversation with the business user, we can list down the business processes and the dimensions that we identify for the processes. Then after that, we can indicate whether each dimension is associated with a certain business process. So this cross indicates, for example, here in the first row, the date, product, employee, customer, customer reseller and customer internal, sales territory, currency, channel. These dimensions are associated with sales forecasting. Then for example, if you take inventory, date, product and employee dimensions are associated with inventory. So likewise, you can see some dimensions are associated with multiple business processes. So these are confirmed dimensions, right? But you can see these two dimensions, they are associated with only one business process. There can be dimensions like that also. So it is easy to have the bus matrix created first before building the dimensional model when there are multiple business processes like this. So we up to now we discussed about the dimensional model on designing a data warehouse. Actually, the dimensional model was what was introduced by Ralph Kimball in 1996, right? This is also called the bottom-up approach. In this approach, the focus is more on data marts, and we focus on the business processes or focus on the departmental processes when building the data warehouse, and the implementation is quite quicker. But this is not the only approach that is there to build a data warehouse, right? There is also what we call the top-down approach. This was the first approach actually introduced by William Inman, right? This approach focuses on the complete enterprise and the implementation is more organizational focused. So previously we learned about the common data warehouse architecture. Now let's look more deeply along these two approaches. So this is the top-down approach. This is what happens in the top-down approach. The data is extracted from different data sources and it's loaded to the staging area. Here ETL is performed, right? So the ETL transformations is performed here and the transformed data is pushed to the data warehouse. This is the enterprise data warehouse, and this will contain the metadata, detailed data and summary data. Then from the enterprise data warehouse, the data marts extract the data and they apply fresh transformations on the data. So these transformations will be synchronized with the structures defined for each data mart. So for each data mart, the structures can be different. So from these, the users can extract the information. Then we have the bottom-up approach by Ralph Kimball. It basically reverse Inman's idea or Inman's model. Data comes from these sources, right, and they are extracted to the staging area. Then they are processed and loaded to the data marts. Now here they are processed and loaded. Then ETL happens and it is used to load the data to the data warehouse. Here the data marts are connected as according to the bus structure that we also discussed before. So the bus structure will contain all the common elements that are used by data marts, such as those confirmed dimensions and measures. So from the data marts, the data is loaded to the data warehouse. Then from the data warehouse, the users can extract the information, or you can see here the users can also straight away connect to the data marts. So these are the advantages and disadvantages of the top-down approach. The advantage mainly we can identify is because there is just one single source of truth, that is all data marts are integrated in one place. It's easy and very flexible, and all the types of reporting needs can be done through the common data warehouse. But the disadvantage is the model implementation can become complex and take a lot of time and need a lot of resources to build this type of model, and more ETL work is needed because data marts are then built from the data warehouse, right? So basically those are the advantages and disadvantages of the Inman's approach. And then when you consider the Kimball's approach, because we are starting from the department level, data marts are then used to build the data warehouse. Only a small team of developers is needed, right? And it will be quick to set up and build the data warehouse, and it will be easy to get all those departmental wise metrics and track the KPIs, right? But the disadvantage is we learned about the data warehouse as like one source of truth for the whole organizations where all the information is available, but that is a little bit violated in this Kimball's model, and sometimes we cannot handle all the enterprise reporting needs because the model is oriented towards the business processes rather than the whole enterprise, right? So these are the advantages and disadvantages of the Kimball's approach. And now we have come to the end of the lesson about data warehousing. I believe you got some basic understanding about the concepts of data warehousing and how it is supporting business intelligence. We learned about different data warehouse architectures, and we learned about the key components of a data warehouse, including the ETL processes, right? And we learned about different data modeling techniques like the star schemas and snowflake schemas, and how they can be applied to different business scenarios. And as some homework, you can also try to familiarize yourself with various data warehouse design tools and platforms. You can do a search and try to find out what are the design tools and platforms that are commonly used in the industry to design the data warehouse, right? So with this, we have come to the end of this lesson. Thank you.